So today we're going to subtract integers using objects to model, much like we did last week with the objects that you had, coins or chips or pieces of candy or cereal or pieces of paper, whatever you were using. We're going to use those same exact models today to do subtraction instead of addition. So a couple of things that I want to go over before we begin. My red chips will be negative. My black chips will be positive. And instead of using physical chips, I'm actually going to use the digital chips that you see here. This will be available to you, a blank version of this in Google Classroom, so you can use these exactly as I am. These stacks have lots and lots and lots of them right on top of each other. They look flat because it's on a screen, but there's actually a bunch of them there, so you should be able to pull over however many you need to complete the problem. Another thing I want to talk about is subtraction. When you think about when you learned subtraction a long, long time ago, you probably learned it as takeaway. I have 5 cookies. My sister takes away 2. How many do I have left? That's exactly what we're going to do today, literally taking away chips out of these piles that we've created. So keep that in mind also. And the final vocab word that I want to refresh your memory on is a zero pair. So that is a pair where you have one positive and one negative, one red and one black in this case, that together, even though I have 2 chips, together their value is 0. Going to be very important for what we do today. So let's look at our first problem. We have 8 minus 2. I know, it's a really easy problem, but those are some of the best ones to start with because you already know what the answer is. So you know right away whether or not what you did worked. Let's begin by modeling this. This is a positive 8. There's no sign in front of it. So I'm going to pull out 8 black chips because remember my black chips represent the positives. And there we have the 8. Now, this is a subtraction sign, which we just discussed means take away. So this is 8, take away 2, positive 2. And I can do that because I have at least 2 positive chips. So here we go. 1, 2. What's left is my answer. Since these are all the same color, black, my answer will be positive. There are 6 of them, so the answer to this problem is positive 6. I know you just rolled your eyes at me because you knew that like 2 minutes ago and you didn't need me to talk about it, but that's how we're going to do these problems. All right, so keep that in mind as we go on to this next example. So we have 3 minus 5, and I really do mean it in that order, not 5 minus 3. That would be written in a different order. This is I have $3 and I have to give somebody 5. I don't have enough. I'm actually going to take away more than I have. So let's model this. This is positive, so there's my 3 modeled with black chips for positive. Now this says to take away 5 positive, but I don't have 5 chips. Okay, so we can add some, but I can't just add them in there because I'm going to change the problem. So let's add in a 0 pair. Now that's a lot of chips, but this pile is still worth positive 3 because remember this is 3 plus 0. So let's do it again. There's another 0 pair. That's a lot of chips on the pile, but it's really worth positive 3 because this is 3 plus 0 plus 0. This red and black together is 0. This red and black together is 0. Now by doing that, I have 5 positive chips. So I can pull away these 5. I was a little delayed. Now what's left, that's my answer. So I had the 3, that big old pile. I took away the 5 that the problem tells me to take away, and what's left is my answer. So my answer is negative 2. 3 minus 5 is negative 2. Now, if you think about that in the problem that I gave you originally, I have $3. I owe my friend 5. I'm going to give you what I have, but I'm still going to owe that person 2. Negative can mean owing. So it makes sense. All right, another problem. We've got negative 6 minus negative 3. And if you remember, sometimes they'll use the parentheses to kind of highlight that this is a negative. That's all they're doing here. They don't mean anything else. So let's think, how am I going to model this problem? This is negative 6. Which color was negative? That's right, the red. So there's my negative 6. Now this tells me to take away -3. Negative is represented by red, so I can just take away 3 red chips. Do I have 3 red chips? Yeah. There they go. And what's left is my answer. And because they're red, my answer will be negative. And because there's 3 of them, the number part is 3. Now, there are some tricks that we'll learn in the coming days, but for right now, I really want you to think about putting up chips, taking some away. All right, let's look at this one. 5 minus -6. This is a positive, so what color will we start with? Black, because that's how we're showing positives. So there's 5 black chips for +5. The problem tells me to take away -6 or take away 6 reds. I don't have any reds, so how am I going to do this? Well, now I have a red, and this whole pile is still worth 5. Remember, because this is 5 plus 0? Well, let's do it again. Still worth 5. Still worth 5, because every one of these paired up is worth 0. So this whole big pile of chips is really worth +5, which is what I started with. Now I can take away those 6 reds, and what I'm left with is my answer. There's 11 black chips, so my answer is +11. And you're like, wait a minute, I took stuff away and I ended up with more than I started with? Well, yeah, let's think about this a different way. Think of positive as heat and negative as cold. If I have heat and I take away cold, heat, take away cold, well, it's going to get hotter, right? There we go. It got hotter. All right. You try this one. Pause it, pause the video, set it up, and when you're done, come back and see how we did. This starts off as -5 minus +1. So how do I set up -5? 5 reds. Take away +1. Well, how do I do +1? 1 black. No, I don't have that. So how can I get that? Add in a 0 pair. This is still worth -5. And now this little guy, bye-bye. What's left? 6 reds, or an answer of -6.